Hey everyone, this is a little video just to go through pretty much what we've covered up to this point. I'll mainly be looking at the assignment 3, but it also applies to assignments 1 and 2, with our two main things so far is the digit place game and the race to n. So I'm just going to walk through how I would go about doing this problem. Um, when I first look at a digit place game and I'm trying to figure out the secret number, I look for the 00. So yeah, I see that one. That's going to be helpful. Oops, wrong thing. I didn't mean to erase it. I meant to highlight it. So I know that 5, 6, and 7 are not in the number. Now, with this one, from there, it gets a little like, oh, God, okay, well, what else could I possibly know? The next thing I'm going to look at is the highest number. So down here, my eyes go to that 2, because I know that either 9 and 1 or 9 and 3 or 1 and 3 would be in the secret number. Now, with D, I noticed that 1 and 3 cannot be together, right? Because there's a 1 in the D place, means that only 1, 3, or 0 are in the number. So I can eliminate the combination of 1, 3, right? So for that guess E then, it's either going to be a 9 with the 1, or it's a 9 and a 3. Okay. And I'm also going to then look at, well, 9 for sure is in the number, right? Because 9 is in both of those. And if 9 is in the number, then from C, I know it's not in the last place. And from E, I know it's not in the first place. So looking at C and E together, 9 must be the middle number. So I'm going to jot that down. 9 is in the middle, or the tens place, however you want to specify the location. Okay. Now I'm gonna maybe look at some cases. Well, actually, let's look at one more thing before that. Going back to that guess C then, I know that 9 is in the number. Then from C, 4 and 8 cannot be in the number, right? Because of the D is there's only one of those numbers that's in it, 4, 8, or 9, and I know it's 9. So 4 and 8 are not in the number. I noticed a good strategy that some of you were using is to jot down all of the numbers and then cross them off as they get eliminated, right? So we know that 5, 6, 7 were eliminated from guess B, and we just figured out that 4 and 8 are eliminated, right? So start to narrow down to a few numbers that are possible. Now, because 4 and 5 are not in the number, now I'm going to look, have the one I haven't looked at yet is guess A. Right? If 4 and 5 are not in the number, then 2 has to be in the number. Right? So I've got my 3 numbers, right? So now 2 is in there. I don't know where it is yet, but I know it's in there. Oops, I don't know where it is. It's not in the middle. I can erase that. 2 is in. Okay, so in summary, I've got 2, and then either with a 9 and a 1, or 2 with a 9 and a 3, right? It's going to be one of those combinations, and I don't know the order yet, but I can play around with that based off of guesses that are there, right? So let's look at the combination of 2, 9, 1. If those are the 3 numbers, what order did they have to be in? Well, it would have to be in that order that I have it in, right? That works, because in D and E, then the 1 cannot be in the first place or the second place, so it's got to be in the third place. And from guess A, 2 cannot be in the middle, and so if 1's in the last place, 2's got to be in the first place, and then we already know that 9 is in the middle. So 2, 9, 1 is a possibility. How about the combination 2, 9, and 3? Well, if that's the case, notice from D and E, 3 cannot be in the second place or the third place, right? So 3 would have to be in the first. And then I already know that 9 is in the middle. And then could I have 2 in the as the ones place in that last digit? Yeah, that works. The only clue I have with 2 in it is right there. So I just know it's not in the middle, but it could be in the last place. So then that's possible as well. So in this case, there's still 2 numbers possible at this stage of the game. So you'd guess one of them, and then you would know for sure what the secret number is for your last guess. Now, what I like to do after I have 1 or 2 guesses at the end, I'll go clue by clue and just make sure each one works. Like if I knew the secret number, is the guess or the clues given correct, right? So that first guess, 425, yeah, I can check it. Those both satisfy, they both have just the 2 and not in the middle, right? B, yeah, neither has 5, 6, or 7. C, both of them have a 9, but not in the last place. And there's no 4s and 8s. D, both numbers have either a 1 or a 3 and not in the place that's specified in D. So that's good. And then in E, both the numbers have 2 of those, right? So in the 291, I have the 9 and the 1 just in the wrong spots, which is a clue of 2, 0, which is right. This one, yep, I have 9 and 3, but not in the right spots, so that's 2, 0. So these 2 are still possible, okay? So there's a how I think about these as I go through, and then I would write it out nicely. I'll show you that in a minute. That was my scratch work. This is not something I would turn in. I'll show you how I would write it out at the end as a summary. Okay. The next thing we'll look at now are the race 2 games. Now this one is race to 4,000. That's a little extreme, nothing you'd want to actually play. But the point is there any generalizations we can make about the rules of this game and the strategies involved and how it applies to any kind of math, right, which is probably the point of all this. So when we started with race to 23, right, let's just look at a race to 23 real quick. Let me go down and just use one of these game boards. I know it's to 25, but if we want to get to 23, right, then I know that I want 20, right? That's because no matter what O chooses, they choose the 21, I take 22 and 23. If they choose 21 and 22, I take 23. I win if I get 20. Same then for 17. If I get 17, then I can get 20 by the same reasoning. If I go back in that pattern, right, skip 2 numbers and then cross the next one, 14, 11, 8, 5, 2. So now I know that if I get 2, I can win. Now, how do I get 2? Well, if I get to go first, I can get 2, right? So I want to go first in this game and then take 2 and then just do the opposite of my opponent to stay on all of those numbers, and I guarantee a victory. Now, if I don't get to go first, I have to go second, then I'm hoping my partner or opponent does not know the strategy, and then I can get on that pattern. So eventually I want to get on the 2, 5, 8, 11, 14, 17, 20, 23. As soon as I get any of those numbers, I can guarantee a victory the rest of the way. Okay, so that's the race to 23 strategy. The race to 24 strategy, we did that with increments of 1 or 2. If I want 24, it's the same idea. If it's increments of 1 or 2, I'm going that same pattern all the way back. And trying to, oops, I totally messed that up. So you gotta be careful when you're doing your pattern. Missing 2 and then checking the next one. I had a 12, 9, 6, 3. So for race to 24, this was race to 23. For my race to 24, I want to make sure I get 3. Again, I know if I get 3, all I have to do is the opposite of my opponent. I stay on that pattern, I guaranteed I'll get 24. So how do I get 3? Well, I want to go second, because if I go second, O goes first, they're going to take 1 or 2, and then I can get the 3, just doing the opposite of what they do. So my race to 24 strategy, go second, do the opposite of my opponent. If I have to go first, get on those numbers if they don't know the strategy. Okay, so You can do this with any number now, just kind of with these increments of 1 or 2. Here's what I notice. Now, 24 is a multiple of 3, and I want to get 3, right? 23, if I divide it by 3, 3 into 23 goes 7 times with a remainder of 2. Notice what I got is a 2. So here's my little pattern. If I take the number that I'm racing to and I divide it by 3, and why am I doing 3? Because the increments are 1 and 2. 1 plus 2 is 3. Look at the remainder, and that's what I want to get, right? So if I got, so say it was a race to 22, 22 would have a remainder of 1 if I divided it by 3. So I'd want to go first and get 1. If it's a multiple of 3, I want to go second and get on multiples of 3. 3, 6, 9, 12. Notice those are all multiples of 3. Okay. So all that said, now if I have something extreme like race to 4,000, well, let's divide it into 3 into 4,000. What's the remainder, right? I think it's 1,333 remainder 1 if I did my division. So remainder 1 is my clue. So what am I going to do? I want to go first, get that remainder, and then do the opposite of my opponent all the way to 4,000. And I'll guarantee that I'll get 4,000. I don't even have to think about it at that point. I win as soon as I get 1. Okay. What this all comes down to are properties of numbers. In this case, divisibility by 3, and what they have in common. And then we can change the increments to change the divisibility, right? So in this assignment, the last thing was this, instead of increments of 1 and 2, you have increments of 1 and 3. So let's look at this raised to 25 with increments of 1 or 3. Will my little rule hold true? Let's try it out. So 1 plus 3 is 4. 4 goes into 25 6 times with 1 left over. So what if I took 1? If I go first and I take 1 and I just do the opposite of my opponent, will I win? Let's try it. Okay, I took 1. My opponent, let's say they'd go with just 1. So that means I'm going to do the opposite, which in this case is 3, right? Because I have choices of 1 or 3. Now let's say they took 3. Then that means I'm going to do 1. And they do 3 again, I'm going to do 1 again. Now they did 1, I do 3. They do 1, I'm going to stick with my 3. Now they're going to try 4, go 3. Nope, I do opposite 1 and I win. So that strategy worked. I went first, took 1, and did the opposite of my opponent. Okay, notice the key numbers I landed on were 25 because I won, and then 21, 17, 13, 9, 5, and 1. I got all of those numbers. Those are the numbers that, yeah, I know if I eventually land on them, I will win. Now, what do all of those numbers have in common? They're all 1 more than a multiple of 4, right? It's because the multiples of 4, 4, 8, 12, 16, I got 5, 9, 13, 17, right? Again, because of that remainder of 1. Okay, so hopefully that helps in solidifying our little strategy for these games. This will be very helpful when you take the quiz number 1, and also when we have our midterm, this kind of stuff comes up. So think about that, you know, try some other numbers, see if this little conjecture works, and go from there. So that's about it. You know, in summary, I can show you, and this is the main key which you can download, but here's how I would actually write out basically what I was saying when I did that problem, just kind of trying to write it out nicely. You notice each time I state something, I'm saying how I know. By guess B, I know this. By guess D, this is true, etc. And so I'm using some deductive reasoning and proving it by the evidence and the guesses. Okay. For these race 2 games, you just want to specify things like, you're going to go first or second. And if you do that, what are you going to take? And then what's your long run strategy? And it's always doing the opposite of your opponent for these. Okay. Some of you have been saying, land on these numbers, which that's another way to say it, which is good. Like this. I want to try to land on these numbers. How do I know it's these numbers? Well, they're all one more than a multiple of 3 because 4,000 divided by 3 has a remainder of 1. So I want to stay on one more than multiples of 3 all the way through the game. Okay, so that's it for now. Hopefully that was helpful, and send questions my way if you have any, and I'll talk to you all later.